the union and intersection of sets. Okay, before we get really into it, I just want to talk about the definitions. So the word union means you have two different sets of items. The union means combine them all together. And we use that symbol that looks like a U, so that should be easy to remember. Okay, but there's also something called the intersection. And the intersection of two sets is talking about what do those two sets share? What do they have in common? And we use, instead of the U, we use the upside down U to stand for intersection. So let's make it come alive a little more by doing some examples. The first example here has to do with finite sets. And when I say finite sets, I mean sets of items that don't go on forever. They're very countable. So you can see set A has 4 items, set B has 5 items, 5 numbers, set C has 3 numbers. Okay, so the first question, A union B. What that means is we're going to combine all the items that are in both sets A and B. So for me to stay organized, I just go from smallest to biggest. And if the item is in both sets, there's no need to duplicate it, no need to write it twice. So 0, then I see the number 3 in B, then I see the number 4 in A, and then we have 6 in B, 8 in A, 9 is in B, and then the number 12 is in both. So if you were going to combine both sets, those are all the items you would have. Okay, let's look at the next question, A intersect B. So the question to get A intersect B is what is shared in both? Okay, so as we look at both sets A and B, A intersect B, I want to find items that exist in both sets. Well, I see a 0 in both sets, not 4, not 8, not 3, 6, 9, and I see 12 in both sets. So the intersection of sets A and B is just the set of numbers 0 and 12. Okay, let's look at A and C. A union C, which means look at the items in set A and set C and combine them all together. Okay, so we have A union C will be the set, I like to go from smallest to biggest just so I don't miss anything. -2, 0, 4, 8, and 12. Okay, A intersect C, which means what items exist in both A and C. So in this case, when we look at A intersect C, what is common to both? I see that in both sets, there's a 4 and an 8. Now let me add one more question here. What if I asked you B intersect C? That means what items exist in both B and C? Well, if you look at set B and set C, there's not any item that exists in both. There's nothing that is common to both. So be careful here. Do not write 0, because if you wrote 0, that would mean there's a 0 in both sets. What you write when nothing is common, there you have two options. You can either write this, which is the null set, it means nothing, or you can write 2 squiggly brackets with nothing in it, which is also a way to write the empty set. Okay, so let's move on to, these are called infinite sets. Now they're called infinite sets because each set has an infinite number of items in them. Look at set C, for example. Set C is the set of all x's where x is less than 9. There's an infinite quantity of numbers that are less than 9. Okay, so it's a little bit trickier when we're doing union and intersection, but we'll give it a try. Usually the strategy is to use a graph to help us, so we'll do that. So for the first problem, when it's talking about C union D, C is the set of all x's that are less than 9, so 9 is an important number, and D is the set of all x's that are greater than or equal to -1, so that's an important number. Let me use a couple different colors. We'll use set C. X is less than 9, that means all the numbers to the left of 9, but not including 9. Okay, that's set C. And then set D is the set of x's that are greater than or equal to 1. So in this case, we could color it in at 1. and greater means bigger. So that is set D. So now we have our picture. So we could answer two questions. We could answer that question, C union D. Union, remember, means combine all. So imagine we were going to take that blue graph and that purple graph and glue them together. What would happen if we did that? Let's use orange. We would get a graph that goes to the left forever and to the right forever. So C union D, there's a couple ways to write it. We can say it's all the numbers from negative infinity to infinity, round brackets with infinity always. Or you can just say all real numbers. Okay, let's redraw our graph for the next one, because in this one we're not doing union, we're doing intersection. Okay, so C is all the x's that are less than 9, that's the blue graph. D is all the x's that are greater than or equal to -1, that's the purple graph. And now we're asking, what's the intersection? Which means, where do both graphs happen at the same time, or where do both graphs overlap? So if you look at this, here is the region where you have both the blue graph and the purple graph happening at the same time. So we'd say C intersect D goes from the interval of -1, including -1 because we have that colored in circle, up until 9, but because we have an open circle here, we put a round bracket. Okay, if you wanted to write it as a set builder notation, you'd say it's the set of all x's where x is bigger than or equal to -1 and at the same time less than 9. Okay, another example, C union F. So let me draw C. We'll make it blue again. C is all the numbers that are less than 9. So there's graph C. What does F say? F is all the numbers that are less than -8. So -8 is a key number there, and we want to be less than, not equal, just less than. So we have everything to the left of -8, and we still have a round circle at -8, and that's set F. So now the question, C union F. So union means combine all. So it's like we're taking that brown graph and the blue graph and gluing them together. If we did that, we would get one graph, like this orange one. So we would get C union F goes from -infinity on the left all the way up until 9 on the right with a round bracket. It's not including the 9. Or if you wanted to write it as a set builder notation, you'd say it's the set of all x's where x is less than 9. Okay, here's 3 more examples with the same sets just to give us extra practice. So again, you always want to start out by graphing. The key number in set C is 9, and in set F is -8. Let's draw the graph. So when it says C intersect F, we want to see where do they both happen at the same time. So you would get C intersect F is just that region that I shaded. So basically it goes from -infinity up until -8, not including -8, or it's the set of all x's where x is less than -8. Okay, the next situation, we've got D and F. The key numbers, D is has -1, -8 and -1. Okay, set D is saying all the x's that are bigger than or equal to -1, that's set D. And set F is saying all the x's that are less than 8, not necessarily equal, not equal in fact, that's F. So the union means combine all. So we glue both of those graphs together, D union F, and there's 2 ways to write this. We could write this as the interval from -infinity to -8 union the interval from -1 to +infinity. Or you can write it as the set builder notation, x less than -8 or x greater than or equal to -1. Okay, let me redraw the same graph for part F, but now the question says D intersect F, which means where do both graphs overlap? Well, as you can see in this case, they don't overlap at all. So the solution is the empty set. So you can write that as that. They don't overlap or they have nothing in common. The intersection is the empty set.